Hi, Mark. Hi, John.
Hello.
Oh, Mark, you're muted.
There we go. Hi, everyone.
Great. Well, I know you guys have a lot to talk about, so we'll get right to it. Go ahead and take it away.
Okay, I'll just wait for the slides to come up. There we go. Well, hi, everyone, and welcome to our demo of a remote yet hands-on robotics class. So I want to set the scene a little. You probably all know that the pandemic has forced many schools to limit access to or even shut down their computer labs. Labs are a real problem for schools. It's quite hard to sanitize equipment after use, and you often can't send expensive equipment home with students if they're working remotely. But labs are also really great for students. In a labs, students practice learning by making. It's hands-on, it's engaging, and it does improve outcomes. They also provide a great collaborative environment for students where they can practice all those important workplace skills like teamwork and project management. So the question that we're exploring with this demonstration is how can we retain the benefits of lab-based work when some or all of the participants are working remotely? And it's an important question because, schools may be working this way on and off for some time, but there are other benefits. In many regions, educational institutions would like to maintain the benefits of remote working, regardless of COVID-19. It allows remote experts to join classes. It enables students that could be in isolation for any reason to continue to work. And it supports new paradigms. For example, you can get a replacement teacher from just about anywhere. Today, we're demonstrating a remote-friendly collaborative class. I'll be taking the role of lead teacher, and I'm joined by John, who's our technical expert. So John, how have we set things up today?
So first, in our lab, we have the Raspberry Pi-based PyTop 4 robot kit. The robot has two servos and two motors, and we've, for the demo, we're just going to use the servos. We've arranged the servos to form a gimbal, and sitting on top of the gimbal, you can see there's a wide-angle USB camera. We can use that to look around the lab. We also have a couple of LEDs mounted on the front of it so that we can, program it to send feedback that we can see. We've got two students in the lab, and they're in separate locations, Mike and Diego, and they're working in the UK. And Mark, you're a teacher. For the folks who are watching, Mark is in Europe. And everyone is going to be communicating together using Teams. So you can advance the slide there if we can. So most of the people watching, Mike and Diego, are familiar with C#. They're C# students. They've done that a bunch. So they're eager to get their hands dirty with the PyTop robot kit. There's one slight problem, of course. The rover is in Diego's lab. Mike is in a separate location. Mark's in a separate location. So to get around this, we've got the robot. It's joined to our Teams chat, and we can send code to it using C# right from within Teams. And that allows us to communicate back and forth and share a working environment. So in our demonstration today, the robot is going to be searching in its surroundings for Pokemon energy cards. And it will be able to recognize them using an AI model that we've trained using Lobe AI.
Okay, well, that's super, John. So we are going to show a little more of Lobe AI later. And for those interested, we're also organizing a separate Twitch with the Lobe.ai team. And we'll go in that Twitch much more deeply into its capabilities. Okay, so today, Mike and Diego, who are our two superstar students, are going to be learning some robotics, training a classification model, and all while interacting in real time with a remote PyTop robot. This class is for reasonably advanced students. However, I hope by the end you'll be able to see that, given some time, it would be relatively easy to use the same approach to learn some more basic coding principles. I want to stress that we're all remote. John is just rising in Seattle. I'm in Andorra in Europe, and Diego and Mike are in lockdown in different parts of the UK. Diego has the rover in his lab, and we're going to be interacting with it via Teams. So John, let's chat about the setup a little bit. Students can program robot behavior, but what does that actually mean? Can you kind of drill into that for me a bit?
Yep. Yeah, so because everyone is sharing the hardware remotely, we needed a programming model that would let the students collaborate in real time. The program is running on the rover. It's a custom program that we built, and it has an embedded .NET Interactive C# kernel running on it. So one of the objects that's exposed in the rover's programming model, we call it rover brain. You can see a little sample here. And it runs in a loop, and the loop has 3 phases in it. It's perceive, plan, and then act. So perceive is used to take an input. We can take pictures with the camera. Plan is used to evaluate what we're seeing. So we can call out to the Lobe AI model and say, did we find an energy card? And then the act is used if we have a plan, if we have some actionable piece of information, we can then act on what we saw. Now, the important part of this is that each of the perceive, plan, and act stages are delegates that can be overwritten by the students independently of one another. So the loop keeps running, but the different delegates can be replaced. And what this allows is different aspects of the overall task. We can iterate on them, and different people can contribute their own tweaks and changes to that model as we go. But Mark, the question that people are going to ask now is, why are we doing this through Teams and not through Visual Studio Code, for example?
Right. I mean, that's a great question. So the answer is that Teams is already deployed in over 50,000 schools, and it's relatively easy to use. Teams, sure, it doesn't offer an advanced coding experience, but it also doesn't require an administrator to set up tunnels and open ports and firewalls in order for everyone to access the robot, which is, it's really a huge benefit for schools. Today, we're going to be showing an early proof of concept. Over the coming months, we plan on advancing this experience, and hopefully in the future, we're going to be running some trials with real schools. We're also providing access for all of you guys watching to the code that was used to create this work. And note that you could actually do most of what you're seeing here using VS Code and notebooks, which is simpler to set up than using Teams, but of course doesn't have the benefits that we've just described of using Teams. So John, how is it that we are connecting the rover to Teams? Tell me a bit about that.
So yeah, like we mentioned, we have an embedded .NET Interactive kernel running on the rover. Now, a lot of folks have seen the .NET Interactive notebook experience running in Jupyter and VS Code. And the thing to understand is that .NET Interactive is really, it's a general purpose server for interactive program. You can embed it, you can stand it up using a notebook, but you can also use other kinds of front ends for it. And so in this case, we have this Teams rover bot that is joined into the chat, and that's our front end. We're using Teams as the front end for code. So you can send code into Teams. It goes over HTTP to the rover. It gets processed by .NET Interactive, and the responses come back to Teams.
Okay, well, I think with that, it's time to go to school. So we're going to show how a class might advance the behavior of our robot. We don't have a lot of time, and we're covering a lot of functionality. There will be, I hope, some time for questions at the end, depending on how things go. And we will provide viewers, as I said, with access to everything, including this script. So if you're interested, you can go and review it again. Clearly, in a real class, we'd be taking things a little more slowly. All right, Diego, how about you share your screen? In fact, you have already for everyone watching. And Mike, let's say hello to the rover.
I don't think waving works, Diego.
No?
I tried earlier.
All right, so there we go. I think you can see that we can, the rover is responding, and we can test the lights and see that they're flashing. All right. Okay, and Mike, have you finished typing there? Yes, you have, okay. How would we ask for help, for example? How do we find out what the rover is capable of?
Well, I'm going to do the same thing as I did when I was saying hello, and I'm just going to say help directly to the rover.
Okay, nice. All right. Well, let's quickly show how we'd use those commands to invoke actions. Can you turn the camera? Let's see what's off to one side, for example.
Yeah, sure. So I'm going to pan 60 degrees.
Excellent. And there we go. Okay, guys, as you can see from the help, we have 3 main objects that we can interact with. There's rover brain, rover body, and resource scanner, as we said before. We can also send general code to the rover for execution. For example, Mike, could you make the rover move its camera from side to side for me?
Yeah, get a bit of shaking action going on. Got a for loop here, just adjusting the pan from side to side with a short wait in between.
All right. So you can see the camera moving around there. Our rover appears to be surrounded by a load of interesting things. And in particular, there's a number of energy cards scattered around in the field of view. So these energy cards are going to play a pretty important part of our work today. We're going to see if we can get to the rover to scan its environment and find the energy cards. And of course, you know, this is a hugely important topic for autonomous vehicles. They all need to be able to perceive, plan, and act. There are applications of this basic model in self-driving cars, robotics for mining or search and rescue, and even within smart cities. So, okay, let's start with the basics and build up. Diego, do you think you could just capture a picture for us?
Yeah, let's try to do that. We got API to do that. I'm gonna use the body is one of the things that we've seen from the docs. I'm gonna use the camera and get a frame, and then I'm use the preview to make a slightly smaller version so I can send P across, because I would like to see the feedback of what the screenshot is actually in Teams. There you go.
Right, okay, so that's a nice shot. But, you know, to be honest, that's probably slightly too wide to be useful for our classification. Can we focus in a little better?
Yeah, sure. We got some additional API to help us with that. On a frame, I can actually focus. Focus will cause that to grab a smaller section in the center, which is quite useful when we're going to do classification to focus our machine learning on parts of the image instead of being confused by the wide angle of the camera we've got.
Nice. All right, so here we have an image, but as we've discussed, we're using Lobe AI to be able to classify objects that we're looking at. So do you think we could show how that works? How can we grab an image and classify it?
Okay, first thing we need to do is that, again, when Mike did the help, we said it was a resource scanner. I can use the resource scanner to connect to Lobe AI. I can run a model straight on the PyTop, of course, but in this case, it's more useful if I do it on my machine. That's going to allow us to do some very quick turnaround if I need to teach something new, or if, for example, I've got something that is wrong and I want to improve. But I'm going to show you that. Now, let's try to move somewhere else and see if we can find anything interesting. Then we go to the location and I use all the stuff we've seen. I wait, and then I'm going to ask the resource scanner to use Lobe AI to classify, and let's see what was the outcome of that.
Oh, we've got a delay.
Yeah, there's a big delay.
Let's try it again.
Or I can just re-eval the sector. Oh, not sure.
Go figure, live demos, hey?
Yeah.
Works every time. Well, let's not get stuck on that for too long. Maybe we can play around with that and show it in a minute. I just want to recap for the audience. We have a rover with a camera and a gimbal. It can take pictures, and we have a model that we can use to classify them. But what could we do with those building blocks, Mike? What sort of experience could we build with that?
Also, what Diego was just mentioning with the frame focusing method is that rather than taking that wide view that we've got of the everything the camera can see, we can split it up into smaller sectors, and we can scan each of those individual sectors for an energy card.
Okay, let's go ahead with that.
Okay. I will send this to the rover. Diego, would you like to chat us through what's going on here?
Well, so now what I'm going to do is then I'm going to create a bunch of sectors. It's going to be quite useful to have our field of view in a grid that we can go and scan through. So I'm going to do a 5x5 grid, and our field of view is now 120 degrees left to right and 45 vertically. And so now we can go through them, and that's going to be the kind of things that we're going to try to go across and find resources and images.
Okay, so I'm going to set up some additional rover behavior here. I'm going to start off by defining a clear state function for the brain. What this is going to do is it's going to reset the camera position, make sure the LEDs are off, and clear out any existing sector data. This will allow us to do some nice little special functionality to clear the state, and you saw the camera reset there. We can use this later on to force a rescan of the environment. But before we do that, we need to define the stages that John mentioned earlier. But before we do that, I'm also going to add another function here, which is going to help us along our way, which is going to allow us to determine when all the sectors have been scanned. And now that we've got that set up, I can start defining the actual stages of behavior. And I'll start with the act stage here. And all we need to do in this stage is move the camera to the current sector. And the tilt controller knows how to find a sector from its coordinates. So next off, I'm going to define the robot's actual perception. In this perceive stage, all we need to do is capture an image of the sector, and to make sure the camera is stable so we get a good image of that sector, I've added a short delay, and then I've used the focus method that Diego showed us earlier to narrow in on that specific part of the image. I've never been very good at planning, so perhaps Diego, you can take care of the plan stage.
Yeah, let's try to do that. So let me put our plan delegate here. So what we're gonna do with the plan now, and I'm gonna use the function that we want to stop if we went across all the sector, and that's when we return no plan. If we have a sector, I'm gonna flag it on, and then I'm gonna try to find the next one that we haven't seen yet. If we go one, we return a new plan, so that in the loop that we had before, we can act on that decision, and your function will go through it and move to the new sector. If we don't find anything else, then we stop, because that means we went across our field of view.
Okay, nice. I just want to make sure everyone understands that this is very collaborative and remote and real time. Diego and Mike are in different locations, and they're both, interacting with this rover independently on different parts of the programming model. So, and as you can see, the rover is actually scanning around and checking its environments. And once all sectors are mapped, it will stop and wait there. So, we've basically got something working around and mapping its environment. What do we do now, Diego?
Well, I want to show you the fact that we set up that classifier, so our resource scanner, to use a model, and I told you I was running that locally. So what that means is that I have an instance of LobAI running here, and as you can see, I have trained it to recognize some of those Pokemon cards, and then every time I capture a frame, I can use that to classify and see what type of energy has been found. Now, the fact that we're not running the model locally, that I'm using this one, is that if there is any change, this model can be updated on the fly without having to continuously upload and transfer things between the devices. It's making everything a little bit faster. And if I were to change, like rejecting or making a correction to this label, my confidence will change. So now I want to use this part to go through and enrich each sector we've got with what kind of an energy card we found so far.
Yeah, that's all. Okay, so I'm going to jump in now and just define a couple of extra important functions on our way. I've got a function here that will let us know whether a sector contains an energy card. It's quite a basic function. And I've got another function here which will add a classification label to the sector using our LobAI model.
Okay, that's great. But how do we know if we've actually captured something? How do we know if it's worked?
Oh, okay, let me answer that. So let's start from where we were before. So let me put back. So this is the plan as we have it now, right? And we got some LEDs. I'm thinking of doing this. I'm gonna use the function that we've got. So after we flagged the sector as visited, I want to analyze the sector using LobAI for an energy card. If we found anything useful, I'm gonna use the LED and blink it so that we can get a feedback about the fact that the rover has been seeing things. And otherwise, no lights. Then after that, we keep going with the loop as we had before. And I'm going also to take advantage of the reset state that Mike just defined, because I want to reset state so that we can go off and see the rover using our new plan, scanning, and hopefully finding things around that would be useful.
Indeed. Well, that's really nice. So we can already see that the rover is indeed scanning around its environment, looking around with the camera there. It's clearly doing the mapping and hopefully classifying what it finds. We can see the lights are blinking there. Mike, can you tell us how, now that it's mapped the environment, how could we actually get to the information and show what it's learning about its environment?
Well, Professor Hardwick, we can query the scan sectors directly. Let me just put that in now. This should return us a table that shows us what we found and how many times we found it.
Let's see if it works.
It'd be nice if it came out with the output.
It would, yeah.
But that being said, we can, like John mentioned before, .NET Interactive is a backend for all sorts of things. So one thing that I can do at this point, we could even try to display the information using VS Code. Let's see if I can get that table. Oh,
nice.
That's what we got.
We will not
Wonderful.
be stopped by Teams.
That's brilliant. That is brilliant. Okay, so we are mapping the environment. We are capturing statistics. I think it's now time for a challenge. What I want is I want our rover to find 3 distinct energy cards utilizing the least amount of power. So once you find 3 cards, I'd like you to stop scanning to save battery. How would you approach that?
Well, challenge accepted. I'm going to roll out another function here that should help us get there. And this will help us determine if we found enough energy cards. Sorry, give me 1 second, excuse me. So first of all, we're going to filter for the sectors where we found an energy card. And then we're going to use the select function to extract the label from each result, remove duplicates by calling distinct. And then we're going to compare the count to the defined number that we're seeking, which will help us to determine whether the challenge has been completed.
Well, sorry, Prof, but I think that function, I think my copy pasted from Stack Overflow.
I've been rumbled.
Yeah.
Damn. Gold star for you, Diego.
Okay, so what we want to do now is that despite of, I mean, that's if it's from Stack Overflow, so it's clearly is a function that's going to work. Therefore, what I can do is that I'm going to use the previous logic that we had, but because now we got the function, I could try to short circuit our termination condition. So if we've seen all the sector, or if we match the goal of the 3 resources, 3 energy cards in this case, we can stop. So yeah, that's cool. And let me use now again the reset so we can get the machine off. And I need to type the right stuff. Okay. This should make it start again.
Right, so all the sectors have been cleared, which forces the plan to start again, and we're rescanning our environment. And again, we should see, I hope, once it starts, there it goes, it's found a card, and it will be continuing in that vein. Let's just wait for that to finish for a second.
Mm-hmm.
And looks like it has. All right, so Mike, how might, or Diego, either of you, how might we query what has actually been found and show what's in the sectors?
Well, what we would have done, what I would have done if we were able to see the rich output in Teams would be to query these scanned sectors and filter the results. But I think I'll hand to Diego to do that in the notebook so we can see some pretty...
Well, just to mention that the interesting part is that here, Prof, I'm still remotely connected. So this front end, I'm using the VS Code extension, like you mentioned, but is connected remotely to the rover. So we're sharing the whole state with 3 different things. And this is the we're gonna look at the sector that we've been through and let's see what we found. So this thing found a fighting energy, awesome. These were empty, a fairy, correct, and it saw this one twice, but then this one is the metal, and so that was the 3 types. So we reached the goal, and we only had to do 7 scan instead of having to go through the entire loop.
The entire
So we
25.
saved quite a lot.
Yeah, that's fantastic. Okay, guys, so that's our demo. It's sad, as demos always are, that I think in 50 different trial runs, we've never had a problem with Teams displaying the output, and it won't this time. But we've also managed to show that you can get around that by using VS Code, which is fantastic. But let's chat about what we have shown in this lesson. Our class is completely remote. Everyone is remote, and we're working together in Teams. Using Teams, we can query the robot and ask it about its capabilities. And we can also send it code to run. We can create, train, and retrain a model for classification. We've used energy cards, but you could use anything, any general household items, fruit and vegetables, whatever, mobile phones at home. Our class can independently advance the behavior of the robot's perceive, plan, and act stages. And this allows the teacher to organize the class into collaborating groups who work on specific behaviors. For example, one group could work on training the model and another on mapping and searching. We've shown that we can do a lot even within quite a constrained environment while working remotely. Note that we've not even driven the rover. We only use the camera. If we added driving in, we'd add a whole new set of exciting problems related to navigating an environment and also robot security. There's a landing page with a lot more information about our collaboration with Microsoft. You can access all the code in the GitHub repository. And remember that everything here is open source. .NET is, of course, open source, but so are our .NET and Python SDKs. They're also available on GitHub too. And you can interact with us within GitHub in the normal way. From this page, from the landing page that we see linked to there, you'll also be able to find the answer to our treasure hunt question if you are interested in that. So go and check it out. And thanks very much. If anyone has any questions, please let us know.
Excellent. That was an amazing, amazing session. You know, it's live when demos take the time that they choose to.
I think it was my code broke it.
So we blame Diego.
Thank you.
Yeah.
Never.
Just kidding. That was amazing. We do have a couple questions that I'd love to cover with you guys in the last few minutes that we have here. So we'll go right to it. From Kathleen, what happens if the syntax is bad to the robot?
I think I can feel this one, seeing as I'm the one who was breaking it. Well, Diego, are we able to share the screen again? Can we get some output out? Is that possible, Diego?
Yeah, we have an example of this one.
Let's put in a bad right line. Here we go.
It's gonna complain.
There we
It's
go.
another copy paste that you've
So
done.
it handles it correctly. Yeah, I mean, Stack Overflow normally works for me. I try very hard.
Mhm.
Oh, that commentary is great. Hate to break it to you, but
Code doesn't run. I know.
You want to let people down gently, really, don't you?
oh
It's
yeah,
important.
it's gonna be sad.
Not live on a conference.
One thing is that behind the scene, we also give rich intelligence. This thing is actually able to use intelligence to answer you back about, you know, what type of code to type, suggestion, but also to show you what's available in the state. So when you connect to the bot with a richer editor, like, you know, Monaco editor, VS Code, and other editor like that, more focused to code editing, you get the whole
Teams
rich
doesn't-
experience.
Teams
Like
doesn't
Teams
have
is
that
not
right
designed
now.
for that. So that was for simplicity and the conversational aspect, but you could see now, like I was using VS Code will give you the full rich experience of intelligence. So even Mike would have got that piece of code right at this point.
Amazing. Well, we
What
are
else have we
right.
got?
Oh, sorry to interrupt you. We are right at time. So thank you all so much for joining us. That was an excellent session. If you missed any of it, you can go watch the recording on the stream. Otherwise, you can reach out to all of these lovely folks on Twitter or out to us if you have further questions. Thank you so much. And yeah, we look forward to seeing you guys again soon.
Thank
Thanks
you.
very much.
Thanks.
Thanks.
Bye.